So now for our final video on more advanced diffraction, let's just start again with the diffraction grating equation we just saw at the end of the last video. Remember that D was the grating spacing. That is the spacing between the slits. Theta is the angle between nth order and zero order beam. That is to say the direction of travel of the two. N is the order of beam, and lambda is the wavelength. So now let's just look at what happens if we play around with this equation, how can we get greater angles, etc. So what can we learn from this equation? What can we learn from this equation? Well, for a given order beam, we see that increasing the wavelength of light will increase the angle of diffraction between it and the central beam. And as we've seen that here we're using violet light, which has a lower wavelength than red light. This has a shorter wavelength, shorter lambda, this is a longer lambda. We can just see from our equation up here, if we increase lambda, if lambda increases, then that just means that if we hold everything else fixed, then sine theta increases, which means that theta increases, which means that we go from a theta like this to a theta like this, that is to say theta increases. And decreasing the slit spacing will increase the angle of diffraction. Because we see here, our D, if we increase, well, we can actually write that sine theta equals n lambda over D. And so if we decrease D, we're going to increase sine theta, which means we're going to increase theta. So decreasing the slit spacing will increase the angle of diffraction. Just an interesting fact about D, if D is the grating spacing, that is the space between the gratings, we can find the number of slits per meter if we just blow 1 over that. So if N is 1 over D, where N is the number of slits per meter, if we have D in meters of grating.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.